Howdy, and welcome to week 2, video 2. We're only going to have a couple of videos this week because we've got our Zoom meetings. We're setting up our groups. I want to keep up with your reading. I'm posting some articles and I'm posting some more videos that are not lecture videos per se, but more background videos with people who actually do data science and analytics. So let's go ahead. So we're going to talk about decision analysis. Now, I'm going to tell you right now. I talked about it last video. You hear me say analysis. You hear me say analytics. I tend to think of analysis as a step in the process, and analytics is the overwhelming process. So when you talk about decision analysis, that's what we want to talk about. How do we analyze this data? Now, we're giving you still the 30,000 foot view. We see the data, we access the data, we store the data, we process the data. As I said before, data is their zeros and ones, their values, their numbers. It's the data in context that gives us information. And now we want to apply something to that information and make it knowledge to make our decisions. So it's a management technique. And for those of you who like math and stat, it's based on mathematical and statistical underpinnings. We try to collect the data, we try to analyze the data. How many times did this occur? How many people clicked on this product? How many times was there this cause and this effect? And so we apply this, but it's not going to be always a one-to-one. So that's what gives us the probabilistic nature, the stochastic nature, that then we have probability. Some people are exposed to factors and get very sick. Some people are exposed to the same factors, get mildly sick. Some people are exposed to the same factors, don't get sick at all, right? So we look at the numbers of those people who didn't get sick, who got mildly sick, who got terribly sick. And it creates a probability that this is going to happen or that's going to happen. And we use a decision tree analysis. Back in the day when I first started in this, they used to call it decision support tools. Um, they use multivariate analysis, regression analysis, probabilistic modeling and forecasting. Basically, they're real world models of, they're mathematical models of real world problems. A model is this. A model is some encapsulation of reality. It can't capture all the world. I can't make a model that describes every possible characteristic of the world and actually predicts what's going to happen. There's too many variables. So we take some encapsulation of reality. We look at something with a purpose. Our model has a purpose. It has a viewpoint. Who's modeling? It has a scope. What's the boundaries of our model? What are we trying to get out of this model? Okay, so if I'm a user of a system, my model might be different, for example, than if I'm the engineer who's putting data into that system. So the model is very much viewpoint specific. So the objective of all this is to figure out how to make good decisions, how to make informed decisions, how to make those decisions traceable back to the data. So I don't go into my CEO and say, I think we ought to get out of that very profitable market that accounts for 20% of our profitability. Based on what data are we going to do that, right? Or I think we ought to get into this market that on the surface looks like it has a high risk. But really, if you look at all the factors, this would be a good time because of this, and this. If you go back to that MarketWatch article, the guy is doing evaluations of the value of companies of what's going to happen in the future based on Glassdoor recommendations from current and past employees. It's a very interesting notion that he's taken. Now, this isn't the only thing he's using. They just highlighted that in the article to help predict problems in companies before they are reported or before even the managers may know they're there. So we use this again in our daily life. We make decisions. We make business decisions in our personal life. Which car do we buy? What kind of financing do we get? Where do we buy it from? How long are we willing to take the risk that I've got to make a car payment for 4 or 5 years or something? And a lot of times you use these tools, that's your intuition. You go with your gut. And you can't really analyze how you made that decision. Another way you make that decision is you might build some simple spreadsheets. I'm going to lay down all the possible outcomes. Let's look at which one's better. And you do some kind of analysis, and you may not realize how you're thinking through this, but you're working scenarios and you're thinking through possible outcomes, and you're picking the one that's most advantageous. Same thing happens when we have a more rigorous modeling process. So we need it, and one of the problems we're going to have, and The words here are a little strong coming up from my student workers, but there's a connection between this, and then there's this need to make the connection, but there's a big need to be able to communicate this. If I'm a manager, I don't want to see data out to nine, uh, decimal points. I want to know what that data means. We like to make mathematical and statistical models that give us qualitative results, give us yes or no, give us more likely than not. Okay, so we need to have that connection between the modeling and the analytics, and then know technically what is that model really telling us. And then a third point would be here, and it's not a learning objective because we don't know how to teach us. How do you communicate that? So let's talk about why you need this. It's not just the force of competition. We live in a globally interconnected world, interconnected environment. There's a change in a country that we think is not going to have an effect, but it does. There's a change in our supply chain that we don't realize is tied because it's so far away from us. So there's all these things going on. It's always we want cheaper, faster, better. We want good, traceable decisions. We want to stay out of trouble. We want to keep profitable. So it's not just the forces of competition, it's also globalization, regulation, compliance. And so this quantitative support is for the decision makers. And this modeling is two distinct parties. And this is the inherent problem right here. There's a model builder, but then there's the model user. There's the decision maker. So the last thing the decision maker wants to do is send through a 57 slide PowerPoint explaining all the parameters that went into it. The decision maker wants to know, what's the model telling me? Tell me how you got there, but don't tell me in technical terms. Tell me in terms that I can understand and convey. I always tell my students there's three steps to explaining technology to a non-technical person. Tell me what the problem is. Tell me what the problem is that I can understand. Then tell me what your solution or your model or whatever is doing to help this. And then tell me that with this model, solution, technology, whatever, how the world's going to be better to address that problem in the first place. So one of the problems we do have is figuring out how to communicate successfully what the power of these models are, the limitations. Every technology has a limitation. For 4 years, I ran US operations for an Israeli company, and I that did reliability, availability, maintainability, RAM, reliability, availability, maintainability for high dollar assets, $1 million assets. How reliable would they be? If circumstances change, could you be able to count on them? Would they be available? When should I maintain them? Because some of these assets, an engine or something, jet engine, it comes down for a major overhaul, it's 18 months. It's several months out of commission, right? And they used a Monte Carlo simulation. It was an excellent technology, but it had a drawback. It required so much data to feed the model that managers didn't like it. They didn't like the cost and expense of putting in all that data. They couldn't see the value that it gave them a very good analysis of what they needed to know. So there's always a limitation, a real world limitation to technology, something that it works on, something that it doesn't. So model builders learn a variety of tools, typically in mathematics and statistics, and there's various fields even within mathematics, but we really need to understand this conflict. My slide maker here made some very strong terms about ignorant and unsophisticated, but you see this in the real world. This is just like the model maker is trying to tell you and speak one language, the decision maker is speaking another. We're working on this problem in the data science, but it's still a problem because people they get oversold. They Google something and they think it's going to be the answer to all the problems. It's not going to give you a clear answer. What it's going to give you is the information and the knowledge and the analysis for a human decision maker to make the decision. At the end, there's always a human in the loop. We talk about artificial intelligence. There's nothing artificial about intelligence. Artificial intelligence is basically based on algorithms created by a human being. So the miscommunication is something we have to deal with as a real world problem because we have to understand this as we go through the course. I'm not going to teach you 5 or 6 years of math and stat, how to put your hands on the keyboard, develop this and all this, because that's not what you want to do. Quite frankly, that's not what I want to do, all right? But I want you to understand how these models are built, what the limitations are, when there are good uses, when there are bad uses, so that you can go out and when someone presents this to you, and usually when we do an analysis, it's not one person doing a model. In many companies, it's a room full of people collecting data, building models, different purpose, scope, viewpoint, bringing these all together. You can better interpret what it's trying to tell you, and you can a word we don't use on the slides is traceability. You can understand where these information and knowledge is coming from, where this data is coming from. And if it's, then that helps you feel confident in its validity. So the technical side, we're just going to talk briefly about. If you have a deterministic model, you put an input in, you always get the same output. It's an equation. Well, these are not the models we're dealing with. We're dealing with stochastic models or probabilistic models. And the best example that we have is weather, because the weather represents a constant change in the probabilities. A meteorologist will tell you we're expecting 1 to 3 inches of rain. We think this is going to happen. Well, gosh, why can't you tell us definitely? Because there's so many factors that it can't be successfully modeled. They haven't figured out yet how to successfully model every single factor. So you will hear them talk about a range, and this is important in a probability. A probability has a mean value, an average value, right? And we tend towards that average value, but there's a standard deviation. There's a range that goes around that value. Now I'm going to close on this. We're talking about data, and we're ultimately talking about decisions. Data is zeros and ones in my book. Data is a number. Here's data for you, 6. Okay, what does that mean? Is it a child's age? June, for the month of June? The number of people who got sick because they took the wrong medicine? What is 6? That's data. Put that data in context, and that gives you information. It's the age of a child. It's the 6th month. It's a number of people. It's the value of something. And it doesn't have to be numeric. The color green. What's green? Well, I don't know. What's the context? From that information, we build facts. And from those facts, we build knowledge. And the better our data is, the better we can get the information. The conundrum is we are swimming in vast amounts of data and figuring out which data is valid. So we want to work with data. It's selfish, useless, but at the same time, we need to know what to pick and choose to put in our models. There's a big controversy now in algorithms of oppression. There's the name of a book, and it just again came out last week on healthcare. How algorithms are designed by people, and there's sometimes biases put in. Not that someone sits down and says, I'm going to make this algorithm discriminatory. It happens sometimes on the training data. They train the algorithms on the data they pick. And guess what? The algorithms will start making biased decisions, preferring one nationality over another, or one sex over another for jobs. And these are not simple little mistakes in the algorithm. These are problems in the data collection. And some of these data problems are not as easily solved as you would think. Amazon shut down a multi-million-dollar project because they could not figure out why their algorithms were biased. Multi-million dollars, like 10 or $20 million. They just shut it down because they didn't want to take the PR risk of having this algorithm be considered discriminatory. So the important thing to take away from this slide, we're swimming in data. Which data do we use? How do we know that data is valid? Data is meaningless unless we give it context. That's information. Information is useless unless we figure out how to build it within world facts and give us knowledge. Does that knowledge give us a decision? The knowledge enables the decision. The decision is always made by a decision human maker. Thank you for staying with me.